We are going to start the new chapter here. We're going to talk about trig functions and their graphs. So these ratios of sine, cos, and tan, and possibly the reciprocals, the cosecant, the secants, and the cotangents. We're going to look at the graphs. We're going to look at the properties. How do we model these using graphing technology? So if I give you a graph, can you determine what the equation was? If I give you the equation, can you tell me specific characteristics of a graph that's periodic? Now, what I mean by periodic is a graph that repeats regularly over a certain period of time, an interval in the domain, right? So that means every so often it'll just start and repeat again, and repeat again, and repeat again. And each iteration, or each cycle, or each revolution, or each whatever, however you want to call it, each of those things are going to be the same. It's regular. Right, the key is that it's regular, so it doesn't change from one iteration to the next iteration. The amplitude doesn't change, the period doesn't change, the midpoint doesn't change, mins and maxes don't change, so everything stays the same. Now, I just threw out a bunch of terms out there too, like what are these things I was talking about? Like, what are these characteristics? And then down here, the mentions what the characteristics could be. What is the period? What's the amplitude? What's the domain? What's the range? That's obvious. The y-intercept. What are my zeros? What is across the x-axis? And there's more to this. Like some things I'm not mentioned here is like phase shift. Where's my vertical displacement? Where's the midline? Where's a bunch of other things? So let's draw this picture out first before we start this chapter. And let's just talk about a few different things. So let's actually draw out a periodic graph. Let's draw out a cos graph, and we also have a sine graph down here drawn out for us. That's already set up. Let's draw out a cos graph. Let's see what a cos graph does. Now, what you remember about a cos and sine is what are they measuring? Like on a point on a unit circle, I just want to mention what on a unit circle. So if I were to draw a unit circle here, and I were to put a point on the unit circle, x and y, the x value, remember, is the cos value, and the y value is the sine value. So what's happening when you're graphing this is that the terminal arm, here's my terminal arm, is going to start rotating at a very constant rate around, like that is my angle, right? So my angle, x here, is going to be changing. It's going to manipulate, right? It's going to start increasing, and as it's increasing, cos x is going to spit out the x values of the points at the end of that terminal arm. So this is going to spin around, and all it's going to do is going to spit out just the x values. Let me show you something about this. Okay, so I found an animation here that helps us kind of describe what is it actually plotting here. So here is a sine graph, okay? So as the sine graph is being produced, you can see the angle is changing at a constant rate. So that means the x-axis here, which is the angle, is changing at a constant rate. And all this is plotting here. You can see it matches up with the y values here. So all the y values are being plotted at different angles across this, and it produces this very nice, smooth sinusoidal graph. Okay? I can turn on the cos graph here. Let's turn off the x one, or the sine one. And you can see what this one's plotting here. It's kind of has to translate a little bit, but here it's plotting just the x values. Here's the x value being represented here, and then it's plotting those x values as well. Okay. Now when this plots, you can see where it starts. Can't really pause this thing, but you see it starts at 1 because the x value at angle 0 on the unit circle, the x value over here is 1. As it starts going upwards, the x values decrease, decrease, decrease. By the time it hits 90 degrees, or pi over 2, the x values are 0. It gets over here, the x value is -1, so that's when it's down at 180 degrees, so down here at pi. And by 270, it's 0 again. And by the time it gets one full circle around 2 pi, it's back at 1. So let's plot that over here and see what this looks like. Okay. So we're going to do for one full circle. So we're plotting just the x values here. This is my x values as this thing rotates around. So when my angle is 0 degrees, my x value is 1, 0. So I'm going to be at the top of my arc here at 1. Okay. Now, I'm going to split this in two. So I'm going to go all the way up to 360 here. So about halfway is 180. I'm going to go 90. And then about 270 right there. So I'm going to put those key points there, the quadrantal angles. Okay. Now, it's only going to be plotting just the x value. So by the time it gets to 90 degrees going straight up, my x value is 0 now. So by the time it gets to 90 degrees, I'm going to be at 0. By the time I'm at 180, so by the time I'm way over on this other side over here, I'm at -1, 0. So my x value is going to be -1. So I'm going to be down here. So that's going to be my min. By the time I get to 270 again, I'm at 0, -1. So my x value is 0. And by the time I get around the circle again, all the way around back to where I was before, I'm back at +1. So it's not going to be a V shape here. As you can see, what I was doing before was more curved, right? So it's going to start off, and you could plug in extra points like when I'm at 45, I'm at √2/2, which is 0.707. So it's not a half, but somewhere up here somewhere. It's going to go down, flatten off here, and then go back up, and then flatten off at the top here. It's not going to come right to a point here. It's going to be more curved at that point. So that's one full rotation. Then it's just going to continue on. And then if you go backwards, it'll do the same thing backwards. So I'll go to 360 right about here, and then 180 here, 90, 270. It's going to do the same thing here. And then it's going to curve upwards. You don't have to be perfect to draw in these, but that's the general shape. Okay, so a period is the time it takes to repeat. So sometimes it's easier just to measure from crest to crest. Now the crest is just the top of the graph. The trough is the bottom of the graph. So you could also measure this from trough to trough. Both of those distances should be the period. I'm using this weird colored thing again. Okay, that's the period. So I can read from here from 0 to 360. So my period for this graph is 360 degrees. Now, if you're in radians, this would be, or 2 pi radians, right? Depends on how you're graphing the graph. My amplitude is going to be measured from, you can see up here, it's the vertical distance from the middle of the graph. So you'll have to first of all determine where the middle of the graph is. So the middle of the graph is the line that cuts it right down the middle. In this case, y is equal to 0. Okay. And then I'm going to measure from there to the maximum point. So I'm going to measure to the maximum, or I can measure it to the minimum point. Because the midline is right down the middle of the graph, it doesn't matter which way you go. And this will always be a positive number. So it doesn't matter if I measure down or up. I always get a positive number from this. So in this case, my amplitude is 1. Okay? It's always going to be a positive number. Okay? My domain, if I don't specify what kind of, if there's a real world question or not, my domain is just going to be XER. My range here is going to be from min to my max, and then I'm just going to put a y in between them, just like we usually do. So in this case, my min is going to be -1. To my max, which is +1, and I should probably put the YER part in there just to complete that. Now my y-intercept in this case is going to start at 1 because that's at angle 0. What is the x value? So when my angle is 0, 0 degrees or 0 rads or whatever happens to be in this case it's degrees, what is my value out? It's 1. So this is my, technically it's my x value, even though it's plotting this in y. My zeros, you notice here, where's it cross? When are my output 0? Well, at 90 degrees. I won't list this off as points here. I'm going to list these off as just 90 degrees, 270 degrees. If my limitation is just this window, I'd also have -90 and -270. but I have a bunch of zeros here. Now, I may want a general term here. So all my zeros, let's just label these thetas for now. I can label this as 90 plus or minus, and I'm increasing or decreasing by 180 each time, going backwards or forwards. So I can put any I there, so I can add or subtract 180 each time. So this is more of a general term for this, for my zeros. Now, a sine graph, so I did plot it for us. Remember what sine represents. Sine represents the y values in the circle. So if I'm down this way, at 0 degrees, my y value is 0. So that's why this graph starts at 0. Okay. By the time I get to 90 degrees, or pi over 2, my y value is 1. So I'm at the top of the graph. This graph up here is 0, 1. So by the time I get to 90, my y value is 1. By the time I get back down to this, back over here, my y value is 0. My x value is -1, but my y value is back to being 0. When I get down to 270, my y value is -1. By the time I get back to the full circle, back to the beginning again, my y value is 0. So I've reached around to the beginning. So my period in this graph is this, or 360, depending which we're talking about. We'll talk about when we represent each one. Like if the question says radians at any point, answer in radians. If it says degrees, answer in degrees. My amplitude, again, is going to be measured from the middle to the top, the middle to the bottom, both the same. So both these graphs, because we're dealing with a unit circle, both these graphs are going to be both 1. My domain for both of these are XER again. My range from the min to my max, so -1 to 1. My y-intercept this time is going to be 0, 0. So when I'm 0 degrees, I have 0 as my output. And my zeros here, if I represent these as theta, start off at 0, or this is not in degrees, sorry. Should be in rads. This one's in rads. Okay. 0, then we have pi, 180. Then we have 2 pi, and we keep on going. So let's say I have a general term here. So my general term is I start off at 0, and I add pi in this time. So pi is the same as 180. So it's very similar to the cos graph, but we're shifted slightly. We started at a different spot. Rather than start at 0, like the sine graph, a cos graph starts at 1, but it has the same shape. If I were to put these two graphs on top of each other, you would notice that they have exactly the same shape of graph, right? Exactly the same shape of graph, but they have a phase shift to them. So a phase shift is the side-to-side translation. We call it, in terms of periodic graphs, we call that a phase shift. We'll get to those later on. We talk about transformations of these graphs. But the graphs, if you were just to shift one graph over, it would just line up perfectly with the other graph. Okay? Put it back over there. Okay. Now what I want to do now is I want to discuss what happens if I change certain parameters on the graph. Now, the standard form, like what you'll see later on, is very similar to a transformation graph. Like this is a function. I could say f of x is equal to sine x. So I could say that. And then what if I start adding things to it? Like what if I start going I put a b in there, I put a c rather than h. For some reason they switched the letters from hk to h and or c and d rather than h and k. But what if I start putting those things in? What do these parameters do to my sine graph? What do they do to these characteristics that I have up here? My period, my amplitude, my midline. My midline right there is at 0. If I translate the graph up and down, I can move that midline up and down too. I can also shift this graph side to side. There's no phase shift to these graphs, but I could do that to the graph as well. So I can change one of these parameters. By changing the parameters, I should be able to change the characteristics of my sine graph or my cosine graph, right? Essentially, they have the similar characteristics. Amplitude starts off at 1. The period starts off as a 360 or 2 pi. The midline for both those graphs were 0. the phase shift. We'll talk about the phase shift when we get to that. So what happens when I change, let's start off with the parameter A. Just 1 second while I get my Desmo out here. And just all right, so here's my Desmos I've created. Just simply created, just put some sliders here for these different parameters, A, B, C, and D. C and D are just like H and K. And they do the exact same thing they would do to any graph, transformation-wise. The A does a vertical stretch. The B does a horizontal stretch by a factor 1 over the B, right? So you have to watch out for that 1 over B. The C is just like the H. It'll shift it sideways, right? We call it phase shift this time, so it phase shifts it sideways. And the D is our vertical displacement, which is the same thing as our vertical translation we had before, so it moves the graph up and down. So that's essentially, it's going to do the exact same thing. But we just want to know how does it affect the characteristics of this graph? How does it affect the amplitude? How does it affect the period, et cetera, et cetera? Okay, so here's my graph here. I'm going to just change this into degrees. Now, if you're using your graphing calculator, make sure you're in the right mode when you do some of these things. So put this in degrees, and we're just going to go to 360 here. Let's just go 30s. So there is my graph. You can see that one full period goes to 360. There's 2 periods, 720, and then I keep on going if I want to, go like 1080. All right. So there I put my step as 30, just to make sure that this shows at 360. If you don't put the 30 there, you may not see a 360 nicely there. Other than that, you can see that my amplitude of this graph right now from the middle of the line to the top is 1, and down is also 1. So my amplitude is 1, so that's good. So what I'm going to do now is I'm going to change my A value and see what happens. Okay? So let's see what happens when I change my A values. I'm not going to do the questions on the notes right now. I'm just going to explore this using Desmos. So let's, my A value is 1. Okay, so that's my vertical stretch factor. So I'm multiplying by 1. So it's not doing anything to the graph right now. So these two graphs, the green graph is going to be the stretched graph that I'm going to change around with, or change parameters. And my red graph right now are the same. My B value is 1, so that's my horizontal stretch factor. It's going to be 1 because of 1 over 1. My C value, I haven't moved side to side, so it's 0. And my D value is also 0. So I haven't done anything to the graph to start off with. So what I'm going to do now is I'm going to change this A value. Let's change it to 2. Okay, so it did typically what we wanted to do. We had a bunch of invariant points on the x-axis. You can see those zeros didn't change, but I've done a vertical stretch about the x-axis. So it's being stretched both ways. And now the top of the graph is at 2. So my amplitude is 2. So my A value is 2, my amplitude is 2. Okay, let's see what happens if I go a little bit more. Let's say I went to 3 this time. Okay, stretch factor is 3. My amplitude is 3 because I measure from the midline, so that's the center line down here. To the top is 3, to the bottom is also 3. And my A value is 3, so my amplitude and my A values are the same thing so far. Okay, let's see what happens if I go to a bit smaller, like a half. Okay, so let's see if I went to a half. My A value is a half, my amplitude is a half. I've done a vertical stretch factor of a half, so it's kind of squished it down a little bit. A value is a half, amplitude's a half. Same thing. What if it was 0? Oh, I usually got flat line 0 times anything, because that's stupid. Okay. What if I went -1? Oh, I took the graph, it reflected it, because that's what a negative A does. It reflects it over about the x-axis, and then multiplies by 1. So my amplitude is 1 still. It's upside down. That's fine. It's being reflected, but the amplitude is still 1. Okay. What if it's -2? -2, so it's being reflected, but the amplitude is still 2. So the absolute value of my A value is my amplitude. Okay, that's good. That's an easy. Oh, that's super easy. So I can look at these and I just state what the amplitudes are. I can say, oh, here's my A value right here. My A value, my amplitude is 5. my amplitude is 3 for this one. Now, the A value is -3. That is my A value. But the absolute value of that, so then just the positive version, my amplitude is always a positive number. It's just going to be 3. Sine x, my amplitude is 1. So that's just the standard graph right there. My amplitude for cos graph, we were just doing for sine graphs before, but remember cos graphs and sine graphs have the same amplitude to start off with. So the effects of A are going to do the same thing. My amplitude for this one. Aha. My amplitude for this one. 2/3. Okay, so that's good. Now what's the range of the graph? Let's see what the range of the graph is. Okay. Let's go back here to Desmos. Right here, looking pretty good. Now what's my range? So let's put 2 in there. Well, this is my max, my min. My max and my min are my amplitude. Now it's going to be, we're going to talk about this later on, but if I had a D value put in there, my graph would move up or down because that's my K graph, right? Now, my min value is related to my amplitude and my D together, my displacement, vertical displacement. Say I was moved up a little bit. Say I was moved up to 1. So my graph now is going to be right at 1. My minimum point is going to be from middle of my graph down, 1 amplitude down. So my amplitude is 2. So I went from 1, so I'm at 1. I go down 2, I'm at -1. If I'm at 1 and I go up 2, I'm at +3. You can see that here. So I'm at +3. So my middle of my graphs here, I'm going to go up 2, down 2. So it is related to your D value as well, but because we don't have any D values here, or my D value is 0, I don't have to include those in my domain and range. So it's just going to go down to -5. It's going to go up to +5. Oh, there should be a Y value, sorry. YER. These are all going to be pretty much the same. -1. I don't even want to do all of them. I just don't think I should do them all because they're just going to be repeated over and over until we start getting to our having a vertical displacement in there that moves the graph up and down as well. So these are all just going to be very similar. -2/3, +2/3, YER. And like I said, I'm not going to do all the other ones. Okay? You always put your lower number, then your min, and then your max, and put the Y in between.